Okay. Uh, Welcome to this tutorial number 3, and we are going to do hydraulic modeling. Uh, we are going to use hydraulics modeling, and that is to do with open channels, and that's river analysis system, and we are going to use GeoRas. But then here, before we can do anything, we need to start saving in a particular folder. Like in this case, let me maybe save it as Nyamwamba GeoRas. That's my folder. Then I can save this in that same folder. I save the arc map to Nyamwamba. Then I save this as maybe GeoRas 1. Okay, well, that's good. So the next thing we shall go to, we add some data. What we need the term for the given area. And in this case, we are going to model River Nyamwamba that is found in River Kasese, in Kasese district. And we are going to model it. And then here we need the shape files, the gathered shape files. I put 2014 districts. And then my area of interest is Kasese, so I can zoom it. But if you are not sure which is which, you can label the districts and label. Okay, I can label the districts. That's Kasese. And then I wish to put the sub-counties. So here, I know River Kasese is within some sub-counties here or divisions. I can select them. I have Google here. I have Kilende. I have Nyamwamba division. Maybe something like that. And this, come on and put this like that. So I can select this as my study area. So I can label this as so here you click home, save it selected, then it's okay. That's a selected area for river within Kasese catchment. So you can see that's our area. So what we need for this, we need to get the DEM for the study area. So I can go to spatial analysis, not spatial analysis. I can go to data management. I go to raster, then raster processing. Then I click. This is them. Put the selected area. Then I tick. Then I can put DEM, Kasese, save. Okay. So that's them for our area. Then we shall need the districts. I mean the rivers. We can go to spatial analysis and we go to waters. Then we go to fourth rivers. In these first rivers, you can select. I'm interested in the river Nyamwamba. You can label it. Oh, yes, you can see this is river Nyamwamba. So you can zoom yes, more. Okay. So I can select river Nyamwamba. I can have it from, let me start it here. I select it. River Nyamwamba. Yes, you can have it. That's river Nyamwamba. So I can select it. Three rivers. Put Nyamwamba. Okay. Okay, good. As you can see, it's a river. It's river Nyamwamba. So the next thing for modeling in GeoRas, we need another raster data, and that is tin. So we shall change DEM Kasese into tin Kasese. Then I save. Okay, good. So that's our tin or our study area. So you can enlarge this. You can enlarge. So that's our river. So the next thing here is we need to collect the data, and that is geometric data of the river system. And in this case here, I will go to GeoRas. And I will first start with amplitude to set the target location. So we are doing GeoRas. Okay, I can take it in that. Then I say okay. And then from there, you can start with RAS geometry by creating but before that, you can layer setup. You select the tin. Good. So you go and create this geometric data files, and that is the streamline, the bank lines, the flow paths, the cross sections. So you can add more again, bank lines. Good. Then you can go again and put flow paths. Okay. So in every message, they tell you complete layer by digitizing features. So that will be our next step. Then you go to cross section. Okay, cross section, cut lines is also done. So there are a lot of other geometric data that you can add on. So all these bridges, that's if you've started your river system and you know at some point there are some bridges or there is a culvert, but it could be a box culvert. So all that you need to know in effective flow areas, maybe if you've identified them, blocked obstructions, land use areas, leaf alignments, leaf points, structures, storage areas. So if all this you've surveyed your river system and you know they are there, then you can also consider them in your modeling. But in this tutorial, we shall go only with these four geometric data sets that we shall import, uh, shall export them into RAS so that we can continue with our modeling. So, well, at this point, you can now start digitizing. But before you digitize, we need first of all to go to editor, and we know what we are editing. So we are editing rivers. Okay, good. So now from here, we can now start digitizing. Okay, we shall start with the river. So when you are digitizing, you can use this for now. We trace our river system. But when you are tracing or digitizing, you start from the upstream to the downstream. So with the river Nyamamba, it originates from the mountains of Moon or Resol Mountains. So we started from here, we continue down as we digitize. So let's go again. That one is done. For the stream center line, we are done. So we we are done with river, so shall go to bank lines. Bank lines are just next to the river system. So can I have something like that? Okay, always start from the upstream to downstream. So you can have something like that. Then after this, we go to flow paths. They are just next to bank lines. Good. So I think we shall go to we go to cross section. Okay, so we've gotten I've forgotten one flow path. The flow paths one should pass through the center line, the river. This so that I trace it. So there's one which passes through the center line. Good. So we can now go to cross sections. good. So after when we are done with this, we can go to the next step, and that is GeoRas. Can go to this one. We are done. This we are done. We are still in the RAS geometry. So we can go to stream topology. So you can save the edits. Okay, river topology is done. Then stream center lines. Field ID. So maybe before that we can. Before that we are supposed to give it the name. And then here I know I'm dealing with river Nyamwamba. Then it's within Kasese. It's okay. Then you can also identify the flow paths. If you are moving from that direction upstream, then that one becomes your left side of the channel. Then this one becomes your right channel. Then the middle one becomes your channel. Okay, good. So after doing that, we can repeat the process. Stream center line created. And also go to stations, also calculated. Then you can also go to elevations. I need to take it down. You can go to so done. So sometimes you may wish to do them once. So you can patch them, all of them here. But for this one, you can also do the same for cross section. So in this case, we are just only extracting the geometric data, cross section stations. Then we can also go to bank stations. And then also go to downstream reach line phase that determines. Then we can go to elevations. Normally we use TIN, that's triangular regional network, to extract the elevations of the cross-section areas. So all that is okay. So we would go to Manning's values. That is if we have that land use Manning table, but I think for Uganda we do not have. Then, or if you have the land use values or the land cover that has the land N values, you can extract from them. But in Uganda, the land cover we have, it doesn't have the Manning's values. So all this, if you consider these other data sets, you would also do the same. So in this case, we can now export this RAS geometry. I can export it to GIS. So it is from GIS to GeoRas now. So I'm exporting this. Okay. Finally exported. So well, good. So at this point, we are done with extracting the geometric data from the TIN or triangular regular network. So we shall proceed this with the next step, or in the next tutorial, how we can work with now GeoRas. Otherwise, thank you so much for viewing.